today's segment, we're going to be covering foundations and the proper installation of them, the choice. And in this particular green home project, we had the options of how to insulate this foundation. It's a poured foundation. Well, we could insulate it on the outside with 2 inches of foam, 2 inches of foam on the inside, or we could have picked out a ICF foundation, which is an insulated concrete form foundation, which has foam on the outside and foam on the inside. But for this particular project, the best use of money, the best bang for the buck was to put 2 inches of foam on the inside. Now there's a lot of other issues that go along with a proper installation of a foundation. What are some of those issues?
One of the things we really want to focus on in a foundation is keeping it dry. And that's the one thing we'll discuss about what kind of options you have to keep the foundation dry and to mitigate water that goes into the foundation. We want to talk about drainage under the slab, drainage along the foundation wall, and how that all hooks with your drain tile and how that's evacuated out of the house. Now in this particular project we used conventional foundation construction and then we added insulation, but there are some other options as far as foundation construction, and Bill can go through some of those options that you have for residential construction.
A couple of the other things that we looked at for alternatives was a insulated concrete foundation or an insulated concrete form foundation. They commonly call them ICFs. We looked at that possibility here, but as Linda has pointed out before, that we have quite a bit of the foundation sticking out of the ground. And then that becomes a problem how to cover the foam on the exterior. There are a lot of products to cover, but you have to look at the actual cost, long term of covering 3 to 4 feet of foam on the exterior. Those products, an ICF, what it has is about 2 inches of exterior foam and 2 inches of interior foam with the concrete poured in between, so it becomes a monolithic pour. So it's very similar to what we have here, except that we have just the foam on the inside. Now there's some studies that have been made that say that a system of concrete with foam on the inside and outside may not even be as effective as having a foundation of concrete with foam just on the exterior. Because we go back, in the 70s we had the kind of passive solar movement of we have mass on the inside of the house. Well, when we have concrete on the inside of the foundation, bare concrete, and foam on the exterior, we find that concrete can absorb a lot of heat and give it off in, say, the evenings or off times. So that's one alternative, an ICF. Another one is it's called a shallow frost-free foundation. And it kind of goes back to the old days when we had slab foundation. It just had concrete, and then we would have a small bit of concrete that goes down, say, a foot into the ground. And they would have a tendency to heave. So what we've learned from the Europeans and the Canadians is that let's go ahead and put 2 inches of foam underneath the slab, put 2 inches of foam over the outside of the concrete down maybe 16 or 18 inches in the ground, and then go horizontally 4 feet with foam. So that way the frost can't get underneath the slab. And that's a very cost-effective method if you really don't need to have that extra storage of a basement or need that extra living space.
Foundations are one of the most important aspects in green construction. A basement is something we want you to consider as a livable space. That means it needs to be warm, dry, and has good indoor air quality. During the initial construction, when we excavated, we made sure that the whole foundation sat on a gravel bed. That allowed good drainage and kept the footing dry. One of the next stages we took a look at is before we put the slab in, we put what's called drainage tile to allow us to drain any water that would be underneath the slab away from the home. That was covered with gravel, and then we put insulation down. That will keep the basement slab warm. Then as we connected the foundation wall to the footings, we put in what's called a capillary break. That keeps moisture from migrating through the ground up into the foundation walls. That's very important in keeping not only your basement dry, but the insulation up above in the regular wood construction. As we backfilled, we wanted to make sure that we didn't have direct contact with the wet soil and the foundation wall. So we put a drainage barrier there. That'll allow a space for any water that comes in contact with the foundation wall to drain away from there. One of the other things we did take advantage of is the fact that with that drainage tile, both inside and outside of the foundation slab, we can connect that to a radon mitigation system that allows us, if we do have a radon problem, to pump that air away before it gets into the home and causes issues with indoor air quality. One of the things that was unique with this particular project is that it was in an area that was an older developed area, and the sewer line was relatively shallow. A lot of these places did not have basements, and so they didn't have drainage issues on the lower floor. We had to actually put in a pump system to allow us to pump any of the waste that is from the basement, such as the floor drain, the washer, if you had a bathroom down here. The other thing you want to take a look at when you site the house is you want to put the foundation wall high enough that as you push the grade back up against the foundation wall, it can slope away from the house. Again, that keeps the basement drier if you're shedding the water away from the house. So when we poured these walls, they were up to 4 foot out of the ground. As we constructed this, that allowed us to keep everything up and out of the mud, but also then when we pushed the dirt back, we could slope this away and keep water away from the foundation. Anytime you excavate for a basement, you'll have additional dirt that you're not going to need because obviously foundation is taking up part of that space. One of the things that we want to look at in all of our resources is to consume the least amount of energy in taking care of them, whether it's recycling or finding another use for them. What we did in this case is we found a couple sources that were very close to our existing site and allowed them to use our excess dirt. That way we don't have all the fuel consumption with shipping that dirt off site.
What we want to show is the application of the foam, hat channel, and drywall behind the drywall that's already here. We kind of missed that as the construction was going on. So we started with bare concrete wall, put 2 inches of extruded polystyrene on, and then a sound channel or a hat channel, just like this, was applied over the foam. Now what this hat channel does is it helps hold the foam onto the wall and it holds the sheetrock away. To apply it, all you have to do is drill through the channel and use a Tapcon screw through the channel, through the foam and into the concrete. And we put these at 2 foot on center. We started off at the bottom, came up at 2, 4, 6. We'll have one at the top. And then this also allows a space between the drywall and the foam to run all of our wiring. So it's a real nice system of insulating a foundation. You can use this on a new foundation or a retrofit.
Now what we just talked about is foundations, and the important things to remember about foundations is to keep them warm and dry. What we reviewed is what we did for a drainage system, extra gravel, drain tile, and then what we did for insulation. It's important to insulate the floor, the walls, to keep that envelope as tight and dry as we can. One of the other important things we talk about in foundations is radon protection. In this project, we took advantage of the drain tile system to also ventilate for radon. Radon is a gas that can seep into your basement unless you remove it before it reaches the interior.
We didn't get a chance to see the radon pit, and we've gone to all these measures earlier on in some of the earlier sessions where we put gravel underneath the slab, we put poly underneath the slab. That's to hold the radon gas down below so that we can get rid of it out of this pit. We'll be attaching a 4-inch pipe that'll go out through the roof, and we can either do it passively, which means that the gases will rise naturally, or we may have to put a fan on to be able to control the radon that's underneath the slab. Iowa has a very, very high radon average, and so the odds are pretty good that we're going to have to put a fan in this particular unit. So next week we're going to start covering framing. That's the best part of the house, I think, Linda. You know, anything that we can do that's carpentry related. So I think we need to move on and start looking at some of the framing issues we're going to do. And so I want to show you one other thing that I saw earlier on the project.
Okay.